Good morning, I am Devisena. In this lecture, we are going to discuss about radio waves and overview. This topic is present in the subject Basics of Communication, that is, how the radio wave is being generated and how it is processed and how the radio wave reaches the radio. These details we are going to discuss in this topic. Radio waves. Radio waves are a type of electromagnetic radiation with wavelengths in the electromagnetic spectrum longer than infrared light. Radio waves have frequencies as high as 300 GHz to as low as 30 Hz. Let us see the electromagnetic wave representation. In an electromagnetic field, we have electric field as well as the magnetic field. The magnetic field vibrates horizontally while the electric field vibrates vertically. This is the representation of the electromagnetic field. And in this, the direction of the wave travel is indicated. The red color wave indicates the magnetic field while the blue color wave indicates the electric field. The magnetic field vibrates horizontally in this diagram and the electric field vibrates vertically, and these two are represented here. Discuss about radio waves. Radio waves are a type of electromagnetic radiation best known for their use in communication technologies such as television, mobile phones, and radios. These devices receive radio waves and convert them to mechanical vibrations in the speaker to create sound waves. A radio wave is not like an invisible string with a sinusoidal shape that moves at the speed of light. A radio wave is made of an electric field and a magnetic field. This is indicated in this diagram. In this diagram, we are having the electric field as well as the magnetic field. This is indicated in this graph. Let us see the nature of radio wave. Waves that, like sound, vibrate in the same direction as the direction of propagation or longitudinal waves. That is, sound waves or longitudinal waves. While waves that vibrate at right angles to their direction of propagation are transverse waves. Radio waves are one kind of transverse wave. See radio waves versus light waves. Radio waves are much bigger than light waves in terms of their wavelength. Radio waves are bigger than the size of atoms in a wall. That is why they go through, while light is a small wave and cannot get through the wall. If the wall is made out of glass, light will go through it. Radio waves penetration reason. Radio waves penetrate through walls because the material does not absorb them in the same way that glass is transparent to light. The wall was conducting, that is metal, they would not penetrate. Even weakly conducting can have an effect. See how radio waves are transmitted with the help of a small diagram. This is the representation of transmission of radio waves. In the radio station, sound waves are generated with the help of the microphone. From the microphone, we are having the sound waves. These sound waves are modulated. Preferably, amplitude modulation is taking place with the help of the audio amplifier. The modulated carrier wave is amplified and it is being transmitted with the help of the transmitter, and from the transmitter the radio waves reaches the broadcasting antenna. This is represented in this diagram. Transmission of radio waves. The radio wave that leaves the transmitting antenna originates as a sound spoken into a microphone. The current is then transmitted to an antenna where the varying electric field associated with the current initiates an electromagnetic wave in the air around the antenna. Let us see what is an amplitude modulation. Amplitude modulation is a modulation technique used in electronic communication, most commonly for transmitting information via a radio carrier wave. In amplitude modulation, the amplitude of the carrier wave is varied in proportion to that of the message signal being transmitted. Preferably in the radios, we are performing amplitude modulation process. The amplitude modulation process is represented with the help of a small animation. This is indicated here. We are having a signal wave. This signal wave is added to the carrier wave, and these two signal waves and the carrier waves are combined together in the form of amplitude modulated wave. This is represented in this diagram. This amplitude modulated wave only going to be transmitted. Let us see amplitude modulation, frequency modulation representation. Nowadays, FM modulation is also taking place in radio wave transmission. These two, amplitude modulation and frequency modulation, is represented in this diagram. Here we are having a representation. Signal wave and a carrier wave is added to the signal wave. In the amplitude modulation, the amplitude of the signal wave is going to be modified. Likewise, in the frequency modulation, the frequency of the signal is going to be modified. This is represented here. Nowadays, we are using FM radio for smaller distance communication. This frequency modulation is used in FM radio. So far we have seen how the signal is being modulated in the station. Now we are going to discuss about transmission of radio waves. Radio waves are transmitted easily through air. They do not cause damage if absorbed by the human body, and they can be reflected to change their direction. Radio waves can be produced by oscillations in electrical circuits. When radio waves are absorbed by a conductor, they create an alternating current. Let us see radio waves in ionosphere region. Ionosphere layer of the atmosphere helps in radio transmission. It influences radio propagation to distant places on the earth. This is the representation of the ionosphere. The region of the Earth's atmosphere between the stratosphere and the exosphere. Ionosphere layer of atmosphere helps in radio transmission. Here we are having a representation. We have the transmitting antenna and the receiving antenna. The transmitting antenna is located in the broadcasting station. This transmitting antenna broadcasts the radio waves. These radio waves hit the ionosphere. From the ionosphere, the radio waves gets reflected back to the receiving antenna. And this is indicated here. Broadcasting of radio waves to radios, a small representation is here. In this diagram, the broadcasting station broadcasts the program that is in the air, and in the air the radio waves are in the form of electromagnetic waves. This is passed in the air. In the home we are having the radio. The radio waves, which is in the form of electromagnetic waves, is received in the radio that is present in our home. Now we see the radio wave receiver, that is the antenna that is present in the radio of our home. This is the representation of an antenna that is available in the radio. And another representation, the antenna that is connected to our radio plays a vital part of receiving the information. The radio waves gets transmitted from the broadcasting station. That wave has to be received to our radio with the help of the antenna. This is indicated in this representation. Let us see the importance of tuning frequency. Here is a representation. Here we are having a transmitter. This transmitter is available in the broadcasting station. The radio waves that is generated in the radio broadcasting station is having a particular frequency. That same frequency has to be received in our radio. Then only the information that is being broadcasted by the particular radio station can be able to receive in our radio. For that, tuning frequency plays a vital role. In our receiver, we are having an antenna. The antenna has to tune the frequency that is being generated in the transmitter side. For that, tuning circuit plays a vital role. Let us see tuning circuit in radio. Tuning circuit plays a vital role in the radio. With the help of the tuning frequency only, we can receive the information from the particular radio station. Another way of representing the tuning frequency. By adjusting the knob in the tuning circuit, we can exactly locate the frequency of a particular radio station. This process is indicated in this diagram. Let us see the parts of radio. So this is a representation of a radio. The radio comprises of antenna for receiving the information that is being broadcasted in the radio station. And we are having a tuning circuit for tuning the radio to the particular radio station. With the help of a tuning circuit, this is being done. And we are having a volume adjustment knob. With the help of this volume adjustment knob, we can listen the program at the desired frequency or desired sound. and we are having a speaker for producing the sound wave. Radio waves to sound waves conversion. Radio waves are converted to sound waves in radio. This sound wave hits the speaker. This is represented in this diagram. Here we are having a speaker. A speaker is present inside our radio. With the help of this speaker, the radio wave is being converted in the form of sound wave. The sound wave now hits the speaker, and because of that, air molecules around the area gets vibrated. This vibration is indicated in this representation. Let us see the equalization process. In sound recording and reproduction, equalization is the process commonly used to alter the frequency response of an audio system using linear filters. Since equalizers adjust the amplitude of the audio signals at particular frequencies, they are, in other words, frequency-specific volume knobs. These equalizers are present in our radio. See a small representation of equalizer in radio. Here we are having the representation of the equalizer that is present in the radio. Another representation of the equalizer. With the help of these equalizers, we can set the sound to our level. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video, means you can share this video to your friends.